Hello and welcome to Apropos, the show about Clojure. And today we have a special Clojure guest who I'll introduce in a moment. First, I'll introduce our panel. We have Mia,
Hi.
we have Ray,
Hello.
I'm Eric, and
Hi.
we have Ray. What's going on?
Hello.
I'm Sorry, Eric. Getting another technical difficulty. And okay, and then our special guest is Zach. Zach, wave to the people. Yay. All right.
Hello.
This is a very special guest because Zach has been active in the Clojure community for, I don't know, many years. Can you say how long?
Inactive for about as long as I've been active, to be honest, at this point. But I started writing Clojure back in 2010.
Okay. Wow. Great. Um, so we're doing guests now more because we did a survey and that was the number one requested thing was more guests. So we're happy to get a bunch of people on and talk to them.
And I am pulling up the questionnaire right now.
Right. We have a questionnaire for our
questionnaire.
guests. We're very professional.
So, Zach, what is your editor of choice?
It depends on the language. For Clojure, I use Emacs. For Java and Scala, I use IntelliJ. And I have recently been going and like teaching myself Python for like the fourth time and was trying out Cursor for that, which I didn't hate, but I suspect as I get more familiar with the language, it would get more annoying. So,
What do people usually use for Python?
that's a good question. I think so JetBrains that does IntelliJ has PyCharm, which I think some people use, but I think a lot of people just use VS Code. I think that's the kind of the standard editor these days.
What about Jupyter notebooks?
Oh, fair point. Yeah, I think that's a particular subset of Python programmers, but that definitely has to rank up there.
Wait. I want to know what kind of subset of Python programmers uses. What is it? Jupyter Knockbox? Is that what you said?
Jupyter
Oh,
Notebooks, data scientists primarily.
Oh, it's a
You must have
Jupyter
heard of
Jupyter with a Y.
Yes, Jupyter with Y.
Yes.
Yes,
Okay. Yeah.
yes.
I've read a ton of documents that have been generated using this. I didn't know that it was an editor.
Yeah, notebook-based programming is pretty neat, right? You get to type and then run the code in the editor, or sorry, in the document.
It's like org mode.
Like org mode, like org mode. Yeah.
Yeah, I think it's interesting. I think it's really a useful sort of like pedagogical tool where you have like this kind of like solution all laid out with the sort of like literate explanation interleaved there. Uh, I know that people do use it to like work through problems, but like it feels more explanatory than it does exploratory in its like usefulness to me. I don't know if that's how other people feel about it, but that's how it sort of landed for me when I've tried to use it.
So I've used it a little bit and it does feel exploratory in the sense that you can be like, this is what I'm thinking. Let me try something like this. And then it doesn't work, obviously, the first time. And so then I'm like, maybe I should try something. And I just make a new one, I just
Mm.
copy it and edit it as opposed to just editing in place. So I have this kind of, it's like rebel driven development, but you have more of a log of like what you were thinking and what,
Oh, so you're not going
yeah.
and like deleting the previous entries, you're just like it's append only?
Yeah, exactly.
Oh, that,
Exactly.
that, that sounds potentially hard to go and follow after the fact, but fair
Yes.
enough.
I'm starting to think about perhaps needing some kind of version control for the Jupyter notebooks.
Mm.
Oh, this is actually when I was working on Elements of Closure, this was like my primary side project was something which was like a first-class exploratory tool where you had sort of branching lines of exploration and the ability to go and kind of reference stuff and sort of make like a DAG kind of thing. And then the idea was from wherever you were, there was a sort of a back path that was like the minimal set of steps that led you to where you were. Um, I still think it's actually a pretty good idea, but I just got really, really like deep into yak shaving. I like worked on how to go and do proper text rendering with the GPU. Like it was bad.
Yes,
Yeah, that's like Knuth level yak shaving there.
I mean, it was pretty cool. I did this thing where I was able to get the entire works of Shakespeare into like on the GPU, and then you could like smoothly pan and everything like this. And I remember when I got this, my wife came back from work and I showed her like, look, I can make the entire works of Shakespeare like spin like a pinwheel. And she just kind of looked at me and is like, so people need this? And
Yeah.
Yeah.
But look at the crisp font. It's
no, no. I mean,
weird.
she really just Philistine, just can't appreciate,
Oh.
She's never gonna watch
Yeah.
this.
But isn't that
yeah.
like the humble UI stuff that Tonsky is doing with Skia
The
and those kind of
rotating
stuff?
Shakespeare.
That's well, I think potentially, but the idea is that that kind of stuff, if you're sitting on the JVM talking to a GPU, you can render everything very nicely, you know.
Yeah, I mean, Skia, last I looked at it, I mean, it kind of follows the same approach that like all the browsers use. I mean, they all use Skia under the covers, which is that they render everything on the CPU and then sort of marshal it across onto the GPU for compositing. And the kind of thesis I had, I mean, this project like metastasized in all these different sorts of ways, but like I had this sort of notion of like if data fits in memory, then you ought to be able to fit a visualization of it like on the GPU. Like there should be sort of a one-to-one correspondence there. And the problem is that like you can't uh like if you want to go and sort of smoothly zoom and pan and be able to kind of like take it in, the Skia stuff is all like pixel aligned. This is why like in the browser you go from like 100 to 110 to 125, right? These are all like different like pixel perfect renderings of that text. And so, yeah, the thing I was doing, which again, like totally insane way to spend my time, but like it allows you to go and sort of smoothly zoom in and out of the thing. It's a completely agnostic as to this and is able to go and do this. There's a talk I gave about this a bit where I did actually show the Shakespeare thing and showed that if you zoom all the way into one of the letters, like it's like perfectly,
Yeah.
shaped and everything. So there is, I think, a little bit of this like 40-year kind of like chain of development of graphics that we're still kind of like trying to go and sort of walk that from one end to the other. And no one really wants to take the time to go and like re-implement everything from scratch, which like, understandable. But we are a little bit locked into how things were being done, back
Yeah.
on, the very earliest graphical UIs.
Surely
To
nothing will
re-implement or not to re-implement, that is the question.
At some point, like our computers are better now. Like they probably made all sorts of assumptions about the size of the memory and like the kind of processors we
well,
had.
in
And
particular, like GPUs are much
yeah,
better.
Well,
exactly.
right, and that is kind of like my personal bu little bugbear. I mean, like now we found a different way to use GPUs to like, their full extent, but like, they are these like weird little vector supercomputers that are just kind of sitting there, and most of the time we are not like unless you are playing games or doing a particular kind of like Gen AI kind of workflow, they're just like sitting there,
Yeah.
and it does feel a little wasteful to me. So yeah, I mean that is something that if I have an infinite amount of time, I'll probably get back to.
That's the thing that I mean I have to confess I haven't done a lot of research on it, but um one of the promises of functional programming was that and Clojure in particular was like we're getting all these cores. And there was a time when it was like doubling every 6 months. Like you got one core, now two cores, now four cores. And it's definitely stopped doubling. So where are all the cores going? They're going into the GPU, right? And so, but we don't have an answer for that. Like the functional programming is not like, doesn't seem like it's got a big answer for taking advantage of the GPU, like it had an answer for the cores.
I mean, no, not really, right? They are very particular kinds of things. I mean, it's actually interesting. Like, I don't know who here was around for the ants demo that Rich Hickey gave back in the day.
Yeah, yeah,
Remember.
yeah.
So, like, Mia, for context, this is something where like this was a demonstration of the value of like the STM model in Clojure, RIP, and the general sort of notion was you had all these like little agents that were going and sort of like autonomously in different threads going and updating their state and all kind of like interacting with the same shared state
It
without
was all safe,
it was
right?
all safe. It
Do
was
that.
like largely non-contending, so like there wasn't a lot of the issues you would have if you had like a single atom that they were all working on. And so like, very cool stuff. However, like yeah, like we just don't have that many different threads that are all sort of operating on the same state. Like it's not a thing. And when your level of parallelism is like in the tens, it doesn't really make nearly as much sense anymore, right? For the similar reasons that the reason that you have STM in a database is because you have a much higher level of parallelism of people going and sort of contending that same state, right?
Becomes very
And
hard to manage. That's very
yes.
hard to manage by, especially if it's just you, you know.
But yeah, I think that that's interesting. I mean, honestly, in 2010, like I remember, I was like fairly confident that the way this was going to go is that we were going to move away from having like the video card as a coprocessor to like built-in FPGAs as a coprocessor. I thought that that was like the way that it was going to go. People were starting to play around with that because like then the idea is that you could go and just like create your own little custom coprocessor for whatever your workload was and sort of pipe out to that. That obviously never happened. I think because it's like even more of a pain in the ass to go and deal with than the GPU is. So
Writing shaders.
RISC-V is coming, and the year of Linux desktop is coming.
So I
No,
have
but
a what question were you answering? How did we get off
oh,
of
the editors, and we were talking about
here?
Editors,
Of
yeah.
course, we need
notebook,
to talk
Jupyter
about
notebook, and
Yeah.
then
font
we're talking about my
rendering.
Yak Shave, and then yeah. So
And
we're still in question one.
Yeah, no,
so you
I wish
remember he
I
had a
could
dag
have
for getting
more,
back
but
to the original point. That was it.
Never get lost.
no, that's the whole point of this is spend half an hour on question one. Uh, all right. What is your closure story?
oh,
Question two.
No, we haven't got all
So
night, Zach. Come on.
yeah, no. So at my very first job out of school, I was working. So in school, I thought I wanted to be like for the first 2 or 3 years, like I wanted to work in the video game industry. I wanted to do graphics programming, and I realized about midway through that that was a terrible idea because it's a terrible industry. But I still was very interested in sort of graphics and all that other sort of stuff. And so my first job was working on UIs for this company called 3VR, which made a video surveillance appliance. And they had a CEO who wanted a quote unquote Minority Report interface for the whole
Oh
thing.
no.
And he's like, you did 3D
Oh.
graphics, that's great. You come right on in. And like
Mhm.
deeply like dysfunctional company environment CEO.
Mhm.
But I guess I didn't really know any better. And so yeah, after a few years of that, I was kind of ready to not work in C sharp anymore. Ready to like I was getting deeper and deeper into like these weird little Windows APIs. I'm like, I never want to think about these ever again. And so I was looking at other languages. And so this is 2008. So I should say, like, I guess really actually started programming Clojure on my own in like 2008 and then doing it professionally in 2010. But like, uh, I like in San Francisco in like my particular neighborhood, like Ruby was sort of the ascendant thing. We were around the corner from GitHub. We were down the street from Engine Yard. Like this was just like the language. And I looked at it and it was like fine. I mean, I should say that my criteria for testing this was to go and do like a little OpenGL application, which is again a really dumb kind of test bed for this stuff. But um, Ruby felt like it was kind of colonized, so to speak. Like it was a very like large community, and it felt like a lot of the opportunities, a lot of the cool little fun projects had already sort of been claimed by someone. And when I looked at uh, who were the sort of like premier people in the community, it was largely the people who showed up first. And so I was kind of thinking, well, maybe there's something new or something a little bit, less contended in terms of this. And so I looked at OCaml, I looked at Erlang. Erlang does not have OpenGL binding, so it was, easy to dismiss. But I was working with a guy named Tom Fallhaber, who was like this kind of old Unix, like Common Lisp head, who was just a director of engineering at my company, and he said that he was playing around with Clojure. And so I gave it a try, and I built an OpenGL app that turned into an OpenGL library called Penumbra. And that was kind of the beginning of my whole Clojure thing. I learned how to write macros and then macros that wrote macros, and like it kind of was all downhill from there.
Yeah, right. It snowballed.
Macros and right macros, the Lisp promise.
So can I ask you, at the beginning you said that you have been out of the Clojure community for a while. Can I ask about that?
Sure, yeah. I mean, so to kind of walk through this, I was doing some open source work, writing various libraries. The one that kind of was the most career defining one for me was this library called Aleph, which was a quote unquote asynchronous network library. But in practice, what it was a demo I threw together in 3 days over the 4th of July weekend in 2010. Because I had gone to a Clojure meetup and people were like, Ring had just kind of started to become like this sort of community standard. And people were asking, like, what does an async ring look like? And I thought that was a cool question, and it was something that like I had no idea about. But basically, I was like, well, there's this library called Netty. I bet I can go and throw together a quick little wrapper around it and like just see how that would work, right?
Yeah.
And I did that. I made a little Hello World like web server kind of demo, and I threw it up there. And I mean, really, this was like kind of more of a like proof of concept, but I called it a library. And this was when Node.js was just kind of like coming into the foreground. And so everyone was like bananas for async everything.
Sure.
And so people paid a lot of attention to this, right? Because this was like kind of one of those major things that modern competitive language needed to have was some sort of async networking story. And as established, right, the person who
Needed
shows
both.
up first. So yeah, so I that like went up on like the front page of Hacker News, and then David Nolan did this like really hilarious thing where he benchmarked it must be stressed a single-threaded Node.js process against my like multi-threaded thing. And he's like, well, we're faster, and that also got on the front page of Hacker News. And people really like were like very intense about this, like way more
And
so
async.
than
Faster and async.
yeah, yeah, yeah. So that was like a thing where I was like, huh, well, that is a lot of people in the community going and like being really interested in this and like starting to go and make like pull requests and like all these sorts of things. I remember like Stu Holloway the day of like made some sort of like small little this is a cleaner kind of implementation like just pull request on the thing, and I only knew him because I had read his book to learn Clojure, so like it was a
Hmm.
like the open source kind of thing, I think, started to feel a little bit more real to me, where previously I'd just been sort of like toiling on my own little like project.
Yeah.
And so yeah, I decided like, well, if people this is what the people want, then I should go and I should like try to make this a real thing, right? I should go and sort of like have a real story for how this ought to work. And so on the basis of that sort of attention, I started talking to some startups that were using Clojure, right? Only startups were using Clojure in those days. Those were the only Clojure jobs out there, and ended up at one called Runa. More that was after I left, acquired by Staples and rebranded as Staples Sparks, if that rings a bell for anybody. And I spent some time there and then moved on to Factual, which was a larger company that was going and sort of making a transition from Java into Clojure. Mostly spearheaded by one very determined man named Aaron Crow, who, if any of you have met him, he's, one of the nicest people and had like 2 years prior talked to me at like some Clojure conference and said, well, if you're ever looking for a job. And so that that was my last professional Clojure gig, basically, because I left Factual not because of any real problem with the people or like the work I was doing. Well, except that a year after I joined, they pivoted into ad tech, and I found that to be like briefly technically interesting, and then just kind of dull and a little embarrassing. Um, and so I wanted to go and get a different job. I looked around at what jobs were available in the Clojure ecosystem, and none of them felt like they were going to help me grow, like or like kind of, give me something that was like a really broader challenge. And so I ended up going and working for Fitbit for a little bit. They had a Netty project that like they needed someone to work on, and I got this really charming email from a recruiter saying, "They asked me to find a Netty expert, and I think you are." Um, and like seriously, like the only recruiter I've ever like maintained a relationship with, because I was just like, "Yeah, you got it, man. You found me." And then after that, but I should say, like, even as I left this, I had started to write elements of Closure, the book. And so I then took a sabbatical or like left Fitbit to go work on the book full time after releasing the first chapter. And I did some consulting for some closure shops and everything like this, but like I was already a little bit on the downward slope, I guess, right, as I was writing that book, which I think does contribute to how that book becomes progressively less about closure as you get towards the end of the book.
Uh,
Um, because I was trying to think about sort of broader things and how the things I'd learned from closure would sort of apply more broadly to software. And yeah, no, I after finishing the book, I went to go work um, on a team at Microsoft Research that was using Scala. And now I am again on the end of my sort of book sabbatical and talking to a bunch of places where, like, kind of by default, I think I'm going to be writing Python. Uh, so that is the way of all things. You just end up at Python at the end of the day.
so we have a question from the chat. Can I do
Please,
that?
yeah.
So you're doing Python now. What do you miss the most that now that you're not working in Clojure?
I mean, I gotta say the REPL, like, I mean, I haven't found like the right sort of workflow. Like maybe if I was using Jupyter or something like this would like kind of be a little bit more interactive. Like I have to say, like I am relearning Python for the nth time because I know that's what I'm probably going to be using, at least at the sort of jobs that I'm talking to. But like I am not by any means someone who's used Python in anger for like almost anything in my career. And so there might be a better workflow than the one I'm currently using, which is basically run it and then have it like, print out some stuff or whatever, or go and put up like a ggplot kind of like thing or whatever. And like it's reasonably fast, but it just like it's it feels a little bit less fluid than the sort of like very incremental thing I could do with the REPL, and that is something that I very much do miss. So
I think that the enduring part of your closure book was not about closure. Because every time we were just talking about elements of closure as a group on my team, and everyone said, "Oh, it's the names." It's the name.
You have a whole thing on, that was the
Yeah.
first chapter, right?
That's the first chapter. Well, I mean, and it
There's
talks
two
about the
chapters
names in
on it.
closure
Yeah.
because I think that like it's good to ground that. Like, you know, I did, like I said, I worked on a second book, which I've not yet finished, but I have hit the end of my allotted sabbatical here, and so it is harder to go and talk about these things in the abstract, right? To like have this sort of specificity, even if you are trying to talk about broader stuff, to be able to say like, and we all know that X, and then being able to use that as sort of an object example of why these things are the way that they are, as opposed to just talking in the abstract. And when you're writing for a broader audience, you just don't have some sort of universal set of practices that you can kind of like bounce the ideas off of. So it's harder. And like that is, there are people who will regularly say like, why didn't you just go and take elements of Clojure and make it like elements of software or something like that? And I'm like, well, I mean, this is almost kind of what I'm trying to do with this second book, and like it's genuinely harder, and I think it is. Well something that's telling is that part of the reason I sort of took a pause on it is that no one really wants to publish it. The academic presses say that it's too applied, and the industry presses say it's too conceptual. Like Princeton University Press said this seems like an O'Reilly book, and O'Reilly did not concur. So like,
Mhm.
um, it's yeah, I'm kind of find myself in a weird place where like I think there's an audience for the book. I mean, I think that like it's harder to sell the publishing industry just because they're shrinking and they kind of have a certain type of thing that they're all sort of looking for, and like fair enough. But
Werewolves in it.
sorry.
What if you put werewolves in it?
Oh yeah, no, that's fair. You know, you gotta get
Drugs and
the
werewolves.
kids, right? So, you know.
Yeah.
But no, I mean it's
Good.
something where like I think it is harder, and I think that there's a reason that this kind of like more broadly philosophical kind of thing that doesn't have that sort of specificity is harder to publish. Like in the course of my research, I found dozens of books in the 90s that fit this same sort of thing,
Mm.
right? And there was just a sort of willingness to go and try that, and also I think just like a general broader confusion as to like what a software book ought to be, right?
Yeah,
And I
Well,
think that
and
people
things
just have
weren't
this
kind of,
dialed in a lot
they
more as to
weren't
like
things
what
developed.
weren't,
sells.
yeah, things weren't broken down the way they are now. You know,
Yeah.
like,
You didn't have like a community that's like, we do Rails and
right.
we do Python and like, and you also didn't even have like a CPU that was dominating, right? Like you had the
No, there was a lot of stuff, and like
one
a lot
chip.
of people had this sort of idea as to what like the universal kind of like unifying abstraction would be. Most people thought it was the object, which I've got a lot to say about how people like talked about objects in the 90s. It's like it's one of the things I keep on coming up against is like, why is there not an intellectual history of software anywhere? Like, no one has actually gone through this and like talked about what people thought was true. And like, why would you go back and read it now unless, you know, you're me, I guess. But like, you know,
It's important.
It
I mean,
is. We don't have a history as a field.
we still have human and computer interaction as a field,
Mm,
but that too has become professionalized.
mm.
And the professionalization, you know, is part of the broader STEM, the broader push to eliminate the arts from the sciences.
Mhm.
You know, it feels like we're not supposed to think these things are important. We're not supposed to think that the why of what we're building is important.
Yeah, I think that that's
That's where
true,
it
but I
comes
also think that
from.
like, I think that like people are a little bit afraid to go and sort of push too hard on the why of what we do because like every past attempt to go and do that has like really not helped us very much, right? Like the 90s is this sort of graveyard of grand unifying theories of software. And I mean, so like there are kind of like two reasons that these books stopped being published, I think. I should say like the 90s and like the early aughts, basically. Like around 2005 is where this really, really fell off. And I think that like you have both an increasing professionalization and like a larger number of people, right? And a much younger cohort, which is sort of the inevitable effect of going and having a rapidly growing industry, but also just like blogs, right? And there's sort of like this sort of idea that like if it's worth saying, you should just go and write it in a blog post, and people will either like pay attention or they won't. And that goes in that kind of only lends itself to ideas of a particular scope, right?
Yeah.
Like, and a lot of those tend to be like little heuristics that people kind of did, or like some sort of object example, right? You were just going to say something?
Oh, when you finished. Yeah.
Okay, yeah. One of the things that I actually kind of came up against in writing this is sort of an increasing frustration with that kind of writing about software design. There's this concept in like philosophy that comes from like this ancient Greek term called this pharmakon, which is a word that meant both remedy and poison, right? Where the kind of idea is anything's a poison in like a large enough dose, or all this sort of stuff. And the idea here is it's something that just kind of has an effect on the outcome. And if you're an expert, then it's curative, and if not, then it's like dangerous, right? And almost every piece of like folk wisdom in our industry follows this pattern, right? So you have like Knuth says, premature optimization is the root of all evil. And if you look at the full quote, he says actually like 3% of the time optimization is good, 97% of the time it's not. How can you tell the difference? I don't know. You figure it out, right? Or like the rule of three that Martin Fowler sort of popularized says, don't go and try to create an abstraction until you've done the same thing 3 times. But of course, it's not the same thing, because if it were the same thing, we'd just be calling the same code. So what makes two things the same? I don't know. You figure it out, right? Like, and so like these things have this kind of like shape of advice.
Yeah.
But really what it is it's like someone who has this like highly defined intuition for a problem going
Mhm.
and saying, well, to me, this is easy.
Yeah.
And like that doesn't actually go and propagate knowledge, right? What it does is it kind of is more mystifying than it is helpful in some ways, right? And like oftentimes you go and you have these sorts of things which say, like directionally you should do more of this or less of this, right? So like people go say, oh, don't abstract too much, right? Or some people say, write code to throw it away, right? And they don't mean that as a universal. They mean like throw away code more often than you do right now, right?
Yeah,
You
right.
the like median audience for this kind of thing.
Sure.
And I'm not trying to go and say that isn't helpful, but it is not a foundation on which you can actually build a theory of like how to write software, or really help people learn how to write software without just kind of doing it for a decade, right? Like this is still our one and only way to go and teach people how to like write good large scale software, is have them do it. And then some of them demonstrate an aptitude, and then they go and they get promoted to like a staff level title or something like this, right? And this is this kind of like up or out kind of like process in our industry. And this is our, like I said, our sort of one and only way to go and sort of discover like who's, quote unquote, got it or who doesn't. Anyway, Ray, you were going to say something. I talked for a while.
No, no, I was to support your point. Actually, I was talking to someone recently about like the AI stuff, because this is very apropos what you're saying, and it's apropos closure. So it's this idea that people want answers, basically. That just ask a question, give me an answer, and don't tell me all about the intermediate steps. In fact, I don't want to know. All I want to do is I want to have a question, tell me the answer, and I'm going to move on. And I feel like this evolution of the way that programming is going is kind of very antithetical to this concept of actually thinking about stuff and realizing that there are better ways, and it's quite the opposite actually. Not yeah, it's antithetical to it. And it's like your pharmacon thing. It's become the poison for our industry because it stops people. It deflects people from thinking about stuff, and the industry feels like it's managed that way as well. That you're not allowed to think about stuff, refactor it, pause, have a moment, make it better. Does it work? Is it good enough? Yeah, ship it and move the fuck on. Is the modus operandi in the vast majority of the industry, and it feels like that's actually a problem to me.
Well, and if you can't, to your point where you're asking something, you just get the answer, a big part of the problem with AI is it's frequently wrong. And if you can't track the path to the answer, then you have no way of knowing where it went wrong or in what way
You
it's
don't know
wrong.
if it's wrong
And you don't
until
know if it's wrong. Yeah.
you know you know what the right answer is.
No,
Then
and
you
no,
can,
yeah,
yeah,
knowing how, being able to find the places where it went off the path, where it went wrong, that's how you produce code that gives you the right answer.
Definitely. I mean, you want that to be a transparent process where you can kind of like follow it step by step. But like Ray, to your point about this kind of very like I don't know, quasi-utilitarian, like, what does it do for our productivity today kind of approach to this. Like, I mean, part of that is just, I don't know, capitalism, but like I also attribute to
sure.
that um like we just don't have a vocabulary for talking about this, right? So if you go and say, hey, this code is like difficult to work with, we
Mm,
don't have a way to go and talk about that. We don't have a way to sort of quantify that. And so the only time that that work ends up getting done is when someone has the social capital within the company to just put their foot down and
mm,
say, we're going to go and we're going to take a week, 2 weeks, whatever, to go and kind of like clean this up. And like that is that authority, like it may be earned, but again, it's like this kind of weird, like by demonstration kind of thing there. And like the fact that they succeeded here and not in some other place doesn't really reveal anything about the nature of like good or bad software, right? It more reveals something about the like power dynamics in that particular
yeah.
like organization or whatever. And yeah, like I think that that kind of opacity and that kind of like just ubiquitously tacit understanding of software just is becoming increasingly kind of frustrating to me as I get further into my career.
Well,
And
and
yeah.
and the other thing is it's becoming more rare just because the industry is growing so fast.
But we're not. Peak hiring for software engineers was in 2019.
Hmm.
The
Well,
industry exploded
uh-huh.
and we are losing
We're losing
junior
people.
developers
Okay.
to uh, badly generated code by ChatGPT.
Yeah, you think it's the chat bots taking our jobs? Is that
It's not that. I mean, they can't do them,
Hmm.
but when your job is
The
checking,
companies are hoping that
Mhm.
that you can.
And when your job is checking code that is written for you by something else, that's a different job than writing code.
Sure. Sure.
And we're losing there were not we've been losing junior developer spots for a while,
Oh,
but we're really losing them now because you also have a lot of senior developers that have the knowledge and the experience to use these code gen tools fairly efficiently.
mhm.
And that means that you're just hiring less. So
Yeah.
hiring peaked for software jobs
Huh.
in 2019.
Wow. I did not know that.
Yeah,
Okay.
I just
I've
saw,
just been operating on the
saw a
assumption
graph
that it's
on
been
that.
like a,
No.
I mean,
been
I think
growing.
that that generally makes sense to me. I mean, I would posit that like probably that is not in response to actual increased productivity, but like mostly
Right.
wishful thinking.
Yeah.
I mean, salaries continue to climb for developers, right? Or at least for on like the sort of senior end of the scale. But I think that there is.
You can't get seniors without juniors, and if there's no more
Well,
juniors.
this is the problem, right? Is that like basically if our only way to go and have people learn how to be a programmer is by doing, right? If this is how like we have like essentially an apprenticeship program in our industry and you can do apprentice level work cheaper, then basically you are just kind of like pulling out the lower rungs on that ladder and it's not clear how anyone gets past that, right? And I mean, I think that this is a kind of a much broader problem than our industry. Like, I think about like people who are going and writing essays in high school, right? And like,
They don't get any
um,
practice writing. They just
well, you
talk.
practice writing. We don't know how to tell people how to write. We go and we have them write a bunch of stuff, and like this is stuff that you have to pay someone to read, right? Like, there's no value to those essays. No one needs you to go and write like a 5 paragraph, book report or whatever. But this is how we go and we transmit this skill. And like the problem is that like the LMs are at this point like able to write at like a high school level. Like they're good at that sort of like very generic formulaic writing. And like I was talking to a friend of mine who has a kid in middle school, and she got tagged by some sort of AI detector or whatever because she wrote something which was probably like a 5 paragraph essay, and she did it with proper grammar and good spelling, right? And
Used to get tagged by plagiarism detectors. Like that's
right.
not new. There is a
No, I mean
standard.
this has been a real problem, but like this is the thing is like there's no value or uniqueness to this stuff, but like the problem here is that the only way that we know how to do this is to have them go and like generate these
Yeah.
kinds of
No,
texts
you're
over and
right.
over again,
The
and this
purpose
has now become commodified. So like what
and
do you do?
and that's the purpose of writing the essay is not to produce the essay. The essays are crap,
Right.
right? Essays are very bad. Most people cannot write, and most people never will be able to write. The purpose of the essay is to learn how to think, how to synthesize an idea and how to not even how to talk about an idea, but at least how to synthesize one. And the document that is produced by the essay is
Is to be thrown
yeah,
away.
that's not relevant.
Yeah, no, I mean, no one's stockpiling like a strategic reserve of like, high
The
school
high
essays or
school, like,
whatever.
oh
He
no.
has them all.
Like, but like, I think that, yeah, and I think that this is very analogous to what we're sort of seeing in the industry, right? Like the point
Mm.
of like junior developers is not to go and like generate valuable code. Like, I generally think about it as like interns are net negative and like first year, like fresh out of school are like maybe net neutral, right? Like in terms of the effort that you're going and the oversight and everything like this. And it takes a while for that to start to like really start to pay dividends, which is why some companies are just unwilling to bear the like risk of going and hiring people who are junior, right? Like you need to go and have a whole system in place to go and kind of make that worth your while. But like the point again is not the output. The point is like what they are sort of learning, and that is the sort of the capital that you're accruing here. And there's a weird fixation on the output, I think. I mean, again, understandable, I guess, but I think that, yeah, that people sort of fundamentally misunderstand what the point of this sort of early career work is. And so they keep on pointing to this, like, look, it generates like serviceable code sometimes. And like what that should be raising is the question of like, okay, so I mean, to my mind, I see this as sort of like a fait accompli. Like, I don't know how we go and sort of put that genie back in the bottle. And so my question is, how do we go and help people who are fresh out of school think about software in a way that allows them to operate to skip those first few rungs, basically,
Yeah.
right? How do you go and sort of get them up onto that ladder without having, some number of years to go and sort of learn by failure?
Well, you have to
I
teach them.
think the problem, as I say, I think what happens is that it's a bit like, to me, it's a bit like it's a class war, actually. I've got to be honest about that, because what will happen is that if you have enough resources or enough funding to simply code for pleasure or write for pleasure or do anything for pleasure, then you will do that. And that will make you an artisan in whatever field you choose. And you will become the senior developer. Yeah. But if you're impoverished, or if you're, at some sort of contingent place, some precarity, then you will be essentially disposed of, because nobody will be interested in funding your apprenticeship. No one will be interested in funding your neutral state. They're only interested in those people that have came round the left, essentially, who have arrived when they're
And
30 years old,
that
with
is
some experience.
one of the explanations for why there aren't more women in the industry is
Mm.
that
Yeah.
when you get to university, like most people who do well already know how to program. They've already been using computers, and the people who got computers in their bedroom when they were kids were usually the boys because they were marketed
Mm.
at
Right.
boys.
And they were socialized to be interested in computers and everything like
Yeah.
that. Yeah.
Right.
And like it sucks working with boys on group projects. It sucks taking a class where it's mostly boys.
Yeah, and so then you don't stick around if you also, yeah, it's true.
But we were getting women into the junior levels quite a bit from boot camps, right?
Mhm.
There was
Mhm.
briefly I mean, I'm a boot camp product, right?
Mhm.
And the because of the economic incentives of our society, these post boot camp jobs, this was actually the first erosion of the junior developer job. Wasn't a response to Gen AI. It was a response to boot camps. And companies started making these apprenticeships for boot camp grads in particular, and they were lower paid than the junior developer job.
Mm.
They frequently had less of a path for promotion. And uh, when you looked at the stats for who was doing boot camps, it was a group of people with a higher diversity of backgrounds and perspectives, which is actually really important when you're building software, right? Because you're building something that is going to be used by a lot of people who are not necessarily from your background. And so
Yeah.
you want to build something that can be successfully used by your user base, which means you want your developer base to reflect the experiences of your user base. And we were getting more of that from boot camps, and then they started getting funneled into these lower paid proto junior jobs. I think my boot camp was half women, and everyone else I know from my boot camp who's still working in software is a man.
Hmm.
Mm.
I mean that tracks, and I mean I think that there is. I actually kind of I wrote about this in I should say the book that I wrote. I've been releasing bits of it as part of a newsletter to just go and kind of like get some of the ideas out there and everything. Explaining dot software, please subscribe. But
It's a
I
good.
did actually write a little bit about. So the book builds on these ideas from this sort of intellectual movement called structuralism, which was sort of an early 20th century thing, which goes and their sort of key thing is ideas are defined in terms of each other, right? You don't like there's no definition that sort of stands alone. And I think that this is very applicable to software because like when we understand our software, like everything is understood in context, right? You don't read a class method without first understanding what the class is, right? You can't understand pop without first understanding stack. And you also can't really understand push or pop separately, right? These are sort of,
Mm.
defined in terms of each other. But in like classical structuralism, a lot of the analysis was on opposites that were sort of defined in terms of each other. And the most sort of classic one that they would talk about is in terms of gender, right? So if you are less masculine, you are more feminine, right? These things are sort of like just opposite ends of a continuum as opposed to free-floating concepts.
You're not allowed to say that anymore.
God, I got some
Cancelled.
feedback
Oh, we
on
just been
this where
canceled.
I'm just like, no, they said it. I don't, oh God, but like I mean,
Yeah, yeah,
honestly, I
yeah.
think that most people who go and talk about like, we shouldn't have gender, like, fine, like,
Well, no,
let's
you're not
go
allowed to
and
say that now
restart
because
language.
everyone's a
But
woman. There was an executive order on it.
Mhm.
in any
Okay,
case,
okay, okay.
I mean, I think that there is both a right wing and left wing objection to what I just said, and like I think that neither of them are really willing to go and admit that like our language is just so mired in this stuff that it's like hard to escape. And the point I make in this post is just oftentimes these different sort of continuums, we kind of like snap them together. We do this sort of like dimensional reduction, and gender ends up getting sort of slapped onto a lot of these. And if you go and you look at the front end, back end continuum in software, you will absolutely see that, right? Because there's this kind of
Mhm.
like surface substance continuum where we say women are more focused on surfaces, right? And this is both like if you imagine someone who's buying makeup, but also someone who's a receptionist, right? Women both are interested in surfaces and are surfaces in like a lot of cases, right? And, a lot of women get pushed into front-end roles when they're early career.
Yep.
And like also when I was at Google in 2010, um, they were going and splitting their interview sort of things into front end roles and other, because the sort of assumption was like, well, we need people who are like good at that stuff, but that stuff that like they're not good enough at like the normal technical screens. So we have to go and create a separate category where they're always kind of like playing in the kiddie pool, right? Like it was definitely a
Right.
two-class system there. And so yeah, there's a lot of really weird kind of
Well,
revanchist like
front-end
stuff
positions
there.
pay less.
Sorry, say it again.
Front-end positions pay less because
For sure.
front-end
Yes, also that
engineering is
because it is seen as something
feminized
which is
immediately.
like, well, anyone could go and like learn how to, do React or whatever. Like this is definitely this kind of very dismissive assumption.
It's dismissed because it's feminized. I
Yes,
think
yes, I
It all
completely
goes
agree.
together,
yeah,
It's
it
all
comes
mapped to
first.
the same
Yeah.
Um,
admissible, not dismissible.
I will say though that like I think that if you go and you start talking about the sort of mid to late career kind of skill set that like makes someone good at sort of larger scale software development, software design, I don't think those skill sets are particularly gendered. Like even in the kind of like cultural norms and everything like this, I think a lot of it is about metaphors and communication and being able to just kind of go and patiently explain the same thing over and over again to a variety of people and everything like that. And
If
and
anything, those skills are also feminized.
they are to some degree, right? But like
Yeah.
and my I mean, this is very much like tilting against windmills, but like part of my hope here is that if you go and you kind of do carve out those first few rungs, which are almost kind of artificially sort of STEMmy, right? Um, then maybe that goes in that kind of if you go and you can kind of make those not absolute hurdles that people need to clear, both sort of conceptually, but also sort of like, I don't know, psychologically.
Well,
You
why?
can go and have a wider pool of people look at what software, in my opinion, is almost likely to become, right? Which is to some degree, you are fresh out of school playing the role of a lead engineer. Like maybe that's something that's going to appeal to a much different set of people, right? Because the skills are still quite demanding, I think, but they are much more linguistic in nature.
The initial hurdle has changed. Remember, you and I met at a Clojure meetup, um, 100 years ago, uh, because we were on the same side of an argument.
Do you remember
And
what the argument was? I have
the
no.
argument was whether programming was closer to
Mm. No, this
closer
is this is a thing I would ask people to be
to the art
provocative,
of
which is
math.
is programming more like math or more like literature?
Yeah, and you were on
And I'm
literature
firmly
side.
team literature.
Yeah, and it was like you and me like standing like on like the kitchen had divided into the math and the literature groups, and
Okay, so I just want to pause here. We're coming up on time,
oh yeah,
Mhm.
and we still haven't asked
we
our
haven't asked him
the
the
really
crowd
hard
pleasing
question.
question.
Yes.
Yeah,
So,
everyone's watching.
Mia, would you?
All right, Zach, you got to choose. You got to pick one of them.
Hmm.
You can define monad or transducer.
Monoid in the category of
No,
endofunctors.
No,
no.
cheater. We gotta have a
Team
rule.
Matt's here.
You gotta go. Sorry, I looked at the set of questions and I noted that you did not disallow this. So
You got us.
It's
um,
just
I
sorry,
I will
wait.
Yeah.
say I will say though that like having gone and used Scala for some number of years, I continue to not find the monad to be a particularly illuminating abstraction. Like to go and say this is a monad tells me relatively little about what the thing is. Conversely, saying something is a monoid, like in the sort of more data sense, like that actually goes and starts to get my mind turning and like how you can go and sort of how that shapes the code that's going to process it, all this other sort of stuff. But like,
I'm right there with you. Like monoid seems way more interesting to me than than monad.
And this is maybe just kind of my particular bent. I work with like kind of data and data structures and all this other sort of stuff. But like in general, I- I've not like, Scala has kind of two dialects, which is like Java plus plus and Haskell minus minus, right? And the team that I worked on was firmly on the Java plus plus side of that, with a few exceptions. And so I didn't really get exposed to, maybe the joy of monads, but like I think that in general, it just to me like I think I get it. Like I don't think that I'm missing anything. I just don't think that if someone describes like something that I talk about in my newsletters, like sort of like where does the explanation start, right? And I think that if you start an explanation saying, well, this is a monad, like that, if you're in Haskell, that tells you maybe how it can be used, but not really what it is, right? Like or at least it's sort of often, I think, like a not particularly illuminating place
It's a
to start.
vibe,
So
Zach.
yeah.
All right, define monoid.
Okay, well, sure. Monoid is something that basically has two sort of key functions in this, one of which is an identity value, and the other which is something that can go and combine two of those things and yield one of them. So, like a set is really easy, but you could also go and like talk about, I don't know, numbers, right? You have zero and you have addition or something like that. Um, and yeah, I think that that's something that's there, and that like when someone says that, I'm like, aha, yes, I kind of get what how this can be used or whatever.
And now define endofunctor.
No fucking clue.
Almost had you.
Yeah, no, no, no. Yeah, I could see where you're going there, and I plead ignorant. So.
All right. Well,
Yeah,
before
so I mean, are we at time? I don't know if you guys have strict limits here. I
we
can go for a
are,
little bit longer if you
No,
want
no,
to,
no, no.
but
someone just came and
Yeah.
looked at this room, which makes me think that I have to leave.
mm,
So do you have anything to plug or anything you're excited about? And we can put a link in the episode description if you'd like us to link to your newsletter, for instance.
yeah, no, I mean, read my newsletter. It's called Explaining Software Design. That's the sort of working title of the book. Yeah, the website is just explaining.software. If you like it. I always like to hear that. If you have ideas, if you have doubts or whatever, I mean, these are all useful pieces. Like I said, this is a sort of a manuscript without a home right now, and I'm trying to go and sort of figure out how to make it accessible and interesting to the broadest audience I can. So, I would appreciate any engagement people want to offer here.
Thank you
Right.
so much for getting kicked out of this conference
Yeah,
room.
they're
So
they're
they're
eyeing us
maybe heads,
angrily.
Okay, guys. Well, please don't get yelled at. But this was a lot of fun. Thanks for having me.
It's Wisconsin.
Thank you,
Everybody.
Zach.
Thanks, and everyone, if you're interested in more, just hit subscribe. We're gonna be on YouTube now, so
Yeah.
uh, we're pleasing the crowd.